You're not ending. This is a first example of relativity. Here's Oscar standing on a railway platform and Frida's in a coach, which is rushing by through. And when she gets near him, she drops the ball, and she drops it and it lands at her feet. So she says the ball has gone that distance. However, because the train is moving this way, Oscar sees the ball land away over here. He says the ball has travelled that distance. So if you ask them, what distance did the ball travel, you get two different answers, and it depends on the point of view of the observer. The same's true if Frida was in a spacecraft rushing along at a much higher speed that we call v velocity, and Oscar's in his space station. They've both got clocks, and they're going to time the flight of this pulse of light from here down to there, and she gets it on her clock, time for Frida. Times the speed of light, tells her that distance. He sees the spacecraft travel this distance, his velocity times the clock measurement, and the light pulse flies this distance according to the speed of light and his time, which gives you a right angled triangle. The square and the hypotenuse is equal to the sum of the squares on the other two sides. You remember that?
I do indeed, yeah.
Well, you can rearrange that to this equation, which is actually the equation of a circle, and that's time for Frida over time for Oscar, the ratio of their times, to the fraction of the speed of light is equal to a circle. And here is a circle of radius 1, like that, and at time for Oscar, he's got 1 here, times passing normally, but Frida's going at a point at 0.8 times the speed of light, and he sees time as passing for her as only at 0.6, because she's constrained to move along this curve. That's motion in space-time, and the faster she goes, to him, time for her appears to be slower and slower. As she comes back down here again, she'll arrive up at stationary at the same time rate of passing as him. But the faster she goes, because she's constrained to follow this is that equation I've just drawn, so it's really quite straightforward.
It sounds like it probably is really straightforward. I need to go through that.
Cheers.